Hello children, welcome to aimsindia's online classes. In today's video, from mathematics subject, pair of linear equations in two variables, topic we are going to discuss. So here children, the equations or the linear equation will be represented by a line. If we have system of equations or pair of linear equations, that two equations will be represented by some lines, two lines. But the nature of two lines may be in different ways. They may not intersect. They may be parallel, or they may intersect with each other, or they may coincide with one another. They may coincide with one another. They may coincide with one another. Like that, the two lines behaves in different manner. Suppose if we have a pair of linear equations in two variables such that a1x plus b1y plus c1 equals to 0 and a2x plus b2y, here y should be there children, b2y plus c2 equal to 0. If we have two equations like this, so the given system of pair of linear equations in two variables, if we solve them or if we try to find solution for these two equations, the situations are either they can have one solution, or either they can have infinite solutions, or they can have no solution. Means they may have one solution or sometimes infinite solutions. Sometimes there will be no solution for the pair of equations. These three conditions exist for pair of linear equations. So according to these three conditions, we can name them with different names like consistent equations, dependent equations, and inconsistent equations. So let's see the definition of them one by one. So if a1 by a2 is not equal to b1 by b2, so here a1, a2 are x coefficients, b1, b2 are y coefficients. If the ratio of x coefficients is not equal to ratio of y coefficients, then the system, means the pair of linear equations, has only one solution. That is, they will be having only one unique solution. And the system of equations, then they are called consistent equations. Means if this condition, which condition, a1 by a2 is not equal to b1 by b2, if this condition is satisfied by the given system of equations, or if the given system of equations, if they obey this condition, then they are called consistent. They are called consistent equations. Then they are called consistent equations. Consistent equations means the equations which are having unique solution or only one solution. Means if the two equations are represented by two straight lines, so they intersect at only one point. So these two lines are examples for lines represented by consistent equations. So they will intersect at only one point, means they will be having only unique solution. Like that, we can name the system of equations basing on this condition. Suppose if a1 by a2 equals to b1 by b2 equals to c1 by c2, which means ratio of x coefficients, ratio of y coefficients, ratio of constants are equal to one another, then the given system of equations, it will has infinite solutions, and the system of equations is called dependent. System of equations is called dependent system of equations. Dependent system of equations. So if this condition is satisfied, then the equations will be having infinite solutions, and they are called dependent system of equations. And in this case, both the lines represented by the system of equations coincides with each other. They coincide with each other. Means, so they intersect each other at infinite number of points. Because both the lines are coinciding with one another, they intersect infinite number of times, or infinite number of points. So that's why we can tell that they have infinite number of solutions. So when the system of equations, if it obeys this property, then it will be having infinite solutions, and the system of equations are called dependent equations. Dependent equations. Suppose if this condition a1 by a2 equals to b1 by b2 does not equals to c1 by c2, means ratio of x coefficients and ratio of y coefficients is equal, but each of them are not equal to ratio of constants. They are individually not equal to ratio of constants. So then the given system has no solution. Then the system of equations, it has no solution, and the system is called inconsistent. And the system is called inconsistent. Inconsistent system of equations. Means the equations which follow this rule and which has no solution, the system of equations is called inconsistent system of equations. So in this case, the equations present in the inconsistent system, or the lines represented by the system, are parallel to one another. They do not intersect at any place, though we extend them in any direction. They are parallel. So these system of equations are called inconsistent system of equations. So like this, suppose if we have two equations, if we have a pair of linear equations, our pair of linear equations is also called as a system. If we have system of pair of linear equations, they may be, if they follow this condition, so then they will intersect at one point, they will have one solution, they will have unique solution, and they are called consistent equations. Suppose if they obey this condition, if they follow this condition, then they will be having infinite solutions, and the system of equations is called dependent system of equations. So in this case, both the lines represented by the system coincide with one another at infinite number of points. So it will be having infinite number of solutions. And the third one, if the equations follow this condition, ratio of x coefficients, ratio of y coefficients are equal to each other, but not equal to ratio of constants, then the given system has no solution, and it is called inconsistent system of equations. In this case, the lines represented by the equations are parallel to one another. They do not intersect at any place. So in this way, we can categorize the system of equations into three types. One is consistent, means only one solution, unique solution. Second one is dependent, means infinite solutions. Third one, inconsistent, means no solution. Okay, children. So next. Next, algebraic methods to solve a pair of linear equations in two variables. So, for solving a pair of linear equations in two variables using algebraic methods, how we are going to solve that we are going to learn. So, in this algebraic methods, the first method is substitution method. So, substitution method. So, the algorithm to find the solution is, if we have a system of pair of linear equations in two variables in this way, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equals to 0. So, there are three methods to solve a pair of linear equations in two variables algebraically. So, first we have to find the value of one variable. Suppose out of x and y, say y in terms of other variable, that is x, from either equation, whichever is convenient. So, from these two equations, from one equation, we have to find out y in terms of x. So, if you want to isolate y, from here, we can take plus c1 that side. It will become minus c1. Next, we can take a1x that side. It will become minus a1x. Next, we will take b1 that side. It will become by b1. c1 minus a1x by b1. Like that, we will find the value of one variable y in terms of other variable x by isolating y from one equation. That is step 1. In substitution method, that is the step 1. So, next is step 2. We will substitute the value of y which we have framed in step 1. In the place of y, we will keep y value in second equation. So, what happens? The equation will be reduced to one equation having one variable. Okay, children, having one variable. So, like that, we will substitute. Like that, we will substitute. Like this, children. Like that, we will substitute and we will find the values. So, while doing examples, we can understand better, children. So, just from one equation, we will find the value of y. We will change the value of y in terms of x. Then that y value we will substitute in second equation, and we will reduce it to equation in one variable. In terms of x, which can be solved. Let's see the example, children. So, find the solution of following system by substitution method. 4x plus y equal to 11, x plus 2y equal to 8. We have two equations. So, from first equation, let's isolate y. This 4x will go that side, minus 4x. So, y equal to 11 minus 4x, like that we can write. Then we will substitute this value in second equation in the place of y. X plus 2 into, in the place of y, we will keep 11 minus 4x. So, x plus 2 into 11 minus 4x into 8. So, if we multiply, x plus 2 into 11, 22. 2 into 4x, 8x equal to 8. 8x equal to 8. Or this x minus 8x is equal to minus 7x. So, this 22 will go that side. 8 minus 22, or minus 7x equal to 8 minus 22 equal to minus 14, or x equal to minus 7 will come downside, minus 14 by, so x equal to minus 14 by minus 7. So minus minus gets cancelled, 7 2 times 14. So x equal to 2. X equal to 2. So we have got the value of x because of substitution method. For finding y, so let's substitute this x equal to 2 in y equal to 11 minus 4x. Because already from first equation, we have derived the value of y in terms of x. After finding x, let's substitute x value in this equation. So in 11 minus 4x, let's substitute x value. 11 minus 4 into 2, 11 minus 8, that equal to 3. So the solution for equations are x value is 2, y value is 3 children. Y value is 3. Y value is 3. Like that, by using substitution method, we can find the equation, children. We can find the equation. Sorry, we can find the solution of the equation. Next, children, another. Next, children, another question. Solve the following pair of equations by substitution method. So 7x minus 15y equal to 2, x plus 2y equal to 3. So let's take any one equation, children. This x plus 2y equal to 3. It is somewhat looking smaller to compare to first one in terms of coefficients. Let's take this. Let's take 2y that side. Now in this we are writing x in terms of y. If we take 2y that side, it will become 3 minus 2y. Now substitute this x value 3 minus 2y in first equation. In the place of x, 7 into 3 minus 2y minus 15y equals to 2. So 7 3 times 21 minus 14y, 7 2 times 14y minus 15y equals to 2. 21 minus 14y minus 15y, similar terms, we can add them. Minus 14 minus 15 minus 29y. This 21 will go to right hand side. Minus 21 plus 2 equals to minus 19. We can write directly. This minus 29, if it goes to RHS, it will become by. So y equal to minus 19 by minus 29. Minus minus cancel. 19 by 29. We have got the value of y. We have got the value of y. For finding x, let's take this equation. X equal to 3 minus 2y. In the place of y, let's keep the value. X equal to 3 minus 2 into 19 minus 29. Or 2 into 19, or if we make it simplify, so x equal to 3 minus 2 into 19, 38 by 29. So if we take LCM, LCM is 29. 29 3 times, 3 9 times 27, 3 2 times 6 plus 2, 8. 87 minus 38. So x equal to 87 minus 38, which is equal to 49. In the denominator we have 29. So x value is 49 by 29. So like that, we are able to find x value and y value by using substitution method. So if you want to verify, you can substitute x value and y value in the first equation, so that LHS will come 2, RHS is 2. It will be verified. Or you can substitute them in second equation and you can verify. Next one. So another example, solve the following simultaneous equations by using the substitution method. Substitution method. So we have x plus y equal to 13, y equal to x plus 3. We have two equations, 1 and 2 equations. So in second equation, direct we have y value in terms of x. No need to again isolate x, already it is isolated. we have y equal to x plus 3. So using this second equation, in first equation, in the place of y, let's keep this x plus 3. So first equation will become x plus 3. X plus 3 equal to 15. 2x plus 3 equal to 15. 2x equal to 15 minus 3. 2x equal to 12. X equal to 6. If you know the value of x, then what is y? 6 plus 3, which is equal to 9. So x value 6, y value 9. These two are the solutions of given system of equations. One minute, children. One minute, children. Okay. Next. Another question. Solve the following simultaneous equations by using the substitution method. X plus 4y equal to 14. 7x minus 3y equal to 5. 7x minus 3y equal to 5. We have two equations. X plus 4y 14, 7x minus 3y 5. So x equal to 4y comes this side, 14 minus 4y. We can isolate x from the first equation. Let's substitute it. Let's substitute it in the second equation. In the place of x, 7 into x means 7 into 14 minus 4y minus 3y equal to 5. 7 into 14, 98. 7 into 4, 28. Minus 3y equal to 5. Minus 28 minus 31. Minus 3. Minus 31y. 98 minus 31y equal to 5. 5 comes this side. Or we can take 93 that side. Minus 31y equal to 5 minus 98. Or minus 31y equal to minus 93. Or y equal to minus 93 by minus 31 cancel equal to 3. So x equal to 2, y equal to 3. This is the solution. Okay, children. So in algebraic methods, this is the first method, children. Substitution method. Substitution method. By using that, we can solve the linear equations and we can find the solutions. Let's learn remaining in our next video, children. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, aimstoday.in, for information regarding online classes, quizzes, worksheets, activities, English tests and coding skills. Thank you, children. Have a good day.